Differential equations, type 2, real world, A, linear motion. In 2002, question 10b, we were given a particle starting from rest and moving in a horizontal line, and its speed v at a time t is given by the equation dv dt is equal to 100 minus v. We're told then in part 1 to find the time taken for the speed of the particle to increase from 25 meters per second to 75 meters per second. So dv dt is, of course, our acceleration. So in other words, we're told that acceleration is 100 minus v, and rather than having to figure out which form of a we're going to use, we're actually given it this year as dv dt. And of course, the fact that our limits are with respect to velocity and we're looking for time would be our hint that we had to use dv dt anyway. So what's our start and our end limits? Well, at the start, we're told it's starting from rest, so therefore the start time will be 0 seconds. The velocity is changing from 25 meters per second. At the end, we're looking for t, and the final velocity is 75 meters per second. So our start time isn't from rest, it's the time taken to increase from 25 meters per second to 75 meters per second. So in other words, we're taking that the initial time at 25 meters per second is our starting point, in other words, 0. Okay, so if I multiply both sides across there by dt, actually we have to rearrange here first. I actually have 100 minus v on the right hand side, so I'm going to actually divide both sides there by 100 minus v. So in other words, I'm going to have 1 over 100 minus v times dv is equal to dt. My upper limit is 75 for velocity and my lower limit is 25. And that's times 100 minus v on the bottom. And my upper limit for time we're looking for, and my lower limit for time is 0. So in other words, we're looking at the change in speed and the time taken to do so. So if I integrate 1 over 100 minus v, we have to spot that that's our log rule. And of course, we have to go to page 26 in our maths tables to spot that. And we have to remember here that we have to be careful that it's the natural log of the denominator here, which is linear 100 minus v, but we also have to divide by the derivative of the minus v, which is of course minus 1. So therefore that gives us minus natural log of 100 minus v. So it's the natural log of the denominator divided by the derivative of the denominator. And my limits are 75 and 25. And if I integrate the right hand side there with respect to t, I end up with t. And therefore that's limits of t and 0. Okay, 26 in the maths tables, I should say. All right, so if I sub in my limits, what do I have? Well, that is going to be my time is equal to minus natural log of 100 minus 75, and in brackets, minus natural log of 100 minus 25. So we end up with minus natural log of 25 plus natural log of 75. So of course, if I just rearrange that, then I can see I need to apply my log rules. And my log rules are in your maths table, page 21. So in other words, when we're subtracting our logs and the bases are the same, we divide. So in other words, 75 divided by 25 gives me the natural log of 3, which is of course 1.1 seconds. So we were getting 15 marks for that. So 5 for setting up our integral, 5 for integrating correctly, and 5 for getting 1.1 seconds. So the second part of the question says, well, how far does the particle travel? Going from rest to a speed of 75 meters per second. So again, if we're looking at part 2, we're looking for how far, so we're looking for distance. Now I know my acceleration is 100 minus v, and if my limits are given to me in terms of velocity and I'm looking for distance, well, I'm going to write my acceleration as v dv ds. So my start limits and my end limits. So at the start, we're told it's going from rest to 75 meters per second. And we're looking for how far does it travel in that time. So starting and change in distance. So if I rearrange there, I'm going to have v divided by 100 minus v dv is equal to ds. And of course, before I can do anything here, I have to spot that I cannot integrate that. So I'm going to take that to the side. And what I'm trying to do here is I'm trying to divide 100 minus v into v. So if I'm doing my long division there, minus v goes into v minus 1 times. If I multiply that back out, I get v minus 100. If I subtract, in other words, change the signs, well, what am I left with? I'm left with a remainder of 100. So what that means is that the denominator divides into the numerator minus 1 time with a remainder of 100, where I can now separate that function out into something that is integratable. Okay, so now I have to put in my limits. So my upper limit for v is 75, my lower limit is 100, that's minus 1, plus 100 over 100 minus v. And then if I integrate ds, my upper limit is s, my lower limit is 0. Okay, and if we're ready to integrate then, well, if I integrate the left-hand side with respect to v, well, minus 1 integrated becomes minus v. And the second part of the function here is 100 over 100 minus v. So again, we have to spot that function there from page 26 of our maths tables. If you can't spot it, take out the 100 and you'll see that you have 1 over 100 minus v. So that means that it's going to be 100 times the natural log of 100 minus v. But of course, we have to also divide by the derivative of the denominator. And if I divide by the derivative of 100 minus v, well, the derivative of 100 minus v is minus 1. So in other words, this part integrated with respect to v is 100 times minus 1 times the natural log of 100 minus v. So the negative sign is coming from 100 minus v differentiated. And that's within the limits of 75 and 0. If I integrate the right-hand side there, then I get s within the limits of s and 0. So if I just tidy up the left-hand side there, that's minus v times minus 100 natural log of 100 minus v within the limits of 75 and 0. So now if I sub in my limits and I tidy up then, well, I'm going to get on the left-hand side minus 75 minus 100 times the natural log of 100 minus 75. And then if I sub in 0, I get minus 0. So minus 0 minus 100 natural log of 100 minus 0 is equal to s. So if I simplify that, well, that's going to be minus 75 minus 100 natural log of 25 plus 100 times the natural log of 100. is equal to S. And if I put all of that into my calculator, then I end up with 63.63 meters. Okay, so we were getting 10 marks for that question. So again, for setting up my integral properly, so having my little bit of long division in there, so we have 5 marks, and then 5 marks for getting my distance. So we have one more part to the question. These golden questions, the ones that sometimes catch people out, the last part of the question. So part 3 says determine the limiting speed v1 of the particle. And it's giving you a hint here. It's saying find the limiting speed. In other words, what is v approaching as t is tending towards infinity? So if we're looking at that, well, what does that actually mean? Well, what we're told is that as time is tending towards infinity and v is tending towards a velocity, that means that the acceleration is tending towards 0. And therefore, what we would have is that our dv dt must equal 0. And what did we get for dv dt? Well, if we go back, we had dv dt was 100 minus v. And therefore, the velocity v1 must be tending towards 100 meters per second. And there was 5 marks going for that. Okay.